All right, guys, so does everybody have the note sheet for 5.6? Everybody have the note sheet for 5.6? Yes, 5.6 note sheet?
Oh, sorry. Yeah, it's my bag.
It's not in your bag, though.
No. Oh, I thought it was yesterday.
No.
Thank you.
You're welcome. All right, guys. Are there any questions on any of the assignments thus far? You're welcome. Questions on any assignments that we've done thus far? All right, guys. If there's no questions on the assignments, we're going to go on and get started today. Now, what we're looking at today is composite of a function, the composite of a function. Now, when I first learned this, or we covered this when I was in high school, the teacher that I had referred to these as fog and goff. Because how we write a composite function is, or as we talk about it, is f of g of x. And the main way we write this notation is f of g of x. And if we look at that, it looks like it says fog, f of g of x. And what this is the shorthand notation for is f of g of x. Now we also have goff, g of f of x. And I thought that was kind of a neat kind of little reminder, fog and goff, because that's kind of what it looks like. And when we work with these here, what we're going to be doing is working from the inside out. So we look at f of g of x, we're going to start off with g of x and then f of x, then simplify it out that way there. And with g of f of x, we're going to start off with our f of x and then go with g of x. So when we look at the first function here, and again, this will make a little more sense when we look at it. So the first thing we're looking at is this here, our f of g of x. F of g of x. F of g of x. Now, what we're going to do is we're going to start in the very inside and work our way out. So I'm going to plug x into g of x. We're going to plug x into g of x. Well, it's not really going to change anything because g of x already has x, yes? Because if I replace every x in g of x with x, we get the same thing, don't we? Because if I replace x with x, it's still just x. So most of the time, instead of saying that, we're just saying, so what is g of x? X squared plus 3, yes? So replacing g of x with its function, x squared plus 3. Any questions on this so far? Now, what is our function f of x? X plus 2, yes? Well, what we're simplifying and finding, do I have f of x anymore? Well, no. Over here I have f of x squared plus 3, yes? So what do? I replaced x with x squared plus 3, yes? So in the function, I'm going to replace any spot where there's an x with x squared plus 3. So what that's going to give us is x squared plus 3 just took the place of x, and then we have plus 2. Any questions on this so far? Now we just need to simplify. Is there anything in front of those parentheses that's being multiplied? Do we have any exponents? Well, no, we don't have any of that, so we can drop those, which just tells us that we have x squared plus 3 plus 2. Guys, Caleb, thank you. Combine like terms. 3 plus 2 is? So f of g of x is x squared plus 5. And that's all we're doing for this here. We're working from the inside out. So we started off by inputting what g of x was, and then input that into our f of x, and simplified. And if I remember correctly, y'all have done these before, it's just been a while. You did some version of this in Algebra 1, but we're just looking at it again. Any questions on f of g of x before we look at g of f of x? You ready to look at the next one? So this one here, we're looking at g of f of x. Now we can talk about this as we're inputting x into f of x, or really just what is f of x? Because our f of x is, but still, x plus 2. So we'll replace x with our x plus 2. Okay, so that gives us the function g of x plus 2. Well, our g of x is x squared plus 3. But we don't have g of x anymore. We have g of x plus 2. So any place there's an x, we're replacing it with x plus 2. So for x squared plus 3 is now going to become x plus 2 squared plus 3. Because all we're doing is replacing x with our x plus 2. Questions on this here? Now we will need to simplify this. So we're going to have to simplify the x plus 2 squared. Well, x plus 2 squared is the same as x plus 2 times our x plus 2. And what is x plus 2 times x plus 2? For almost, because you're just missing one term. Because when we distribute, we would do x times x, which is x squared, which you got. X times 2 is plus, and then we do plus 2x plus 4. Because our 2 times x would give us the second 2x, and then 2 times 2 would give us our 4. So it ends up being that x plus 2 times x plus 2 is our x squared plus 4x plus 4 would be what that is. But we still need to combine the last two terms. 4 and 3 gives us plus 7. So this here is our g of f of x. G of f of x. Questions on this here? Questions on any of this here so far? Is this the same as f of g of x for these two functions? For these two functions here, was f of g of x and g of f of x the same thing? No, because f of g of x is our x squared plus thought. These here are two separate functions. For the most part, again, for the most part, f of g of x and g of f of x aren't going to give us the same thing. And there's only a certain group where we start talking about, especially with addition, subtraction, powers, that this works out to give us the same type function. And we'll look at those tomorrow. The only other way that most likely we'll end up with the same thing is if we're talking purely about multiplication and numbers. We might end up in the same type. But are there any other questions on these composite functions so far? All right. Let's look at the next one. Let f of x be the cubed root of x plus 1, and g of x be 2x minus 4. So the first one we want to find is f of g of x. Now we can do exactly like we did in the last one and say f of g of x. And we can write out f parentheses g parentheses x, close parentheses, close parentheses. But if I were working this out, I would just start here and say f parentheses, what is g of x? And I don't have to rewrite f of g of x and then input g of x. We can go on and just put it g of x in. Well, our f of x function is our cubed root of x plus 1. Well, we don't have x anymore. We have minus 4. So every place there's an x in our f of x function, we're replacing with 2x minus 4. Questions on this here? No? Okay. Well, this is just going to give us the cubed root of 2x minus 4 plus 1. Any questions on how we got to this point here? Now we can look at the parentheses around our 2x minus 4. Is there anything being multiplied by it or that we need to change? Or can we just drop those parentheses? We can drop them because there's nothing in front being multiplied. It doesn't have an exponent. We can drop them and combine our only like terms. Negative 4 plus 1 is negative 3. And that's it. That's all we have to do for this here. Because the only way we could simplify it is if I could have had something inside that cubed root that was to the third power, then we could simplify it in some way, but 2x minus 3 is to the first power, first degree. There's nothing we can do with it. So this here is our final answer. Questions on this here? Any other questions on anything we've done so far? We good with this here? Questions? Let's look at this one here, g of f of x. So we can go on and put what f of x is. F of x is the cubed root of x plus 1. So again, we start from the inside going out. So we'll start off with replacing f of x with what it is, our cubed root of x plus 1. Now they tell us g of x is 2x minus 4. But for this one here, we're replacing x with our cubed root of x plus 1. Since for our function g of x, we replace the x and g of x with our cubed root of x plus 1. In the function 2x minus 4, we're replacing x with the cubed root of x plus 1. Now, whenever we multiply like roots, so if we multiply two cube roots together, we would multiply what's inside. But here we have 2 in a cube root. They both don't have radicals. We can't just multiply what's inside. We're just doing 2 times the cube root of x plus 1. I do not know. That's actually it. Yeah. I enjoy teaching and I enjoy math. Yeah. Funny story, because this has been a few years back. Friends of ours live out in Fayetteville area. We were out there, I think, went to the mall, did something, went to get Starbucks. Until the last year, I really don't drink coffee. So I just go with them because everybody else does. They were getting their order, and they look around to kind of get in that little, as everybody does in that little group, you stand around and wait for your drinks. They tried to find me, and they couldn't find me, standing around. So they looked around the store. They found me sitting next to some girl. I don't know who she is, still don't. Sitting there. Turns out she went to the U of A, and she was getting ready for her math final. They look over. I'm helping her get ready for her math final. Actually teaching her the stuff that was on her final. Just ran into her and just started teaching in the middle of a Starbucks. Or just reaffirming it, because by that point I think I was almost finishing up my undergrad. So 2 degrees so far. I have a degree for secondary education with teaching and a degree in mathematics. I am almost finished with my master's in education with an emphasis in mathematics.
So why aren't those college teachers yet?
So I could teach probably at a junior college level with a master's. To teach at a college level, I would need a doctorate, which would be another 5 to 10 years. Pretty much. Yeah. A little bit. It depends on the program. So we're going to do one more of this type and look at another type, and then we're actually done with this here. So I want to look at one of these here. Actually, let's change this up. Let's look at g of x. Yep. g of x. All right, guys, let's focus back in. So we're changing this one here from f of g of x for this here to g of x. Now, looking at this here, what is our function g of x? 3 times x plus 5. So what we're going to do is we're going to place g of x, replace it with its function, 3x plus 5. Now, all the ones we've done up to this point has either been f of g of x or g of f of x. And at this point here, we would take it and plug it into the other function. We would replace x for f of x. But here we have g of 3x plus 5. So again, we're coming back to this function, g of x. But we don't have x anymore for g of x. We have g of 3x plus 5. So we're going to replace the x in g of x with 3x plus 5. So we're going to have 3 times 3x plus 5 plus 5. Question?
So this is gonna throw us off the topic again, but like back to your story.
Yeah.
You just go up there and be like, "Hey, you need help?"
Yes.
Yeah.
I think it was mainly because since she was working on math.
You didn't care if she called you a weirdo though?
Nope.
You were like, "Oh my god, help."
Because already in the category of weird or weirdo, because like math, so.
No, I don't like you didn't think? It's like,
No.
what happened if she, you didn't know she could kill you? I don't know.
Why she could come up to me and be like, hey, you want me to do math for you? I'd be like, oh.
What happened if she threw something at her face? No, I know, but like, worst
Probably.
case scenario. I don't know.
Yeah, but probably my focus at that point was more on the math than it was anything else.
You were just like, what you doing?
Probably.
Oh my god. Okay, sorry.
All right. So we only have one more. We just need to simplify this and we're actually done. So we just need to multiply through with the 3. So 3 times our 3x is 9x. 3 times 5 is going to be plus 15 plus 5. Which gives us exactly 9x plus 20, which is our g of x. And that's all we need to do for this here. Any other questions on these composite functions? Mm-hmm. All right. We're going to skip over the next one and go to example 2, evaluating a composite function. So we're going to look at evaluating these composite functions. Now, when we evaluated our functions yesterday with multiplication and division, and when we evaluated the functions last Friday with addition and subtraction, we found out what f plus g of x was, and then plugged the value in for that equation that we got. Guys, thank you. So what we worked with last week and yesterday was when we found f plus g of x, how we actually had to find out what the expression was and then plug the number in. Here, with these, we don't have to do that. We're going to still, like I said at the start, we're going to work from the inside out. We're going to work from the inside out. And the first thing that we have is g of 3. Trey, thank you. What we're going to do for this here is we're going to plug 3 into g of x. We're going to plug the number 3 into g of x. Well, our g of x is x squared plus 2. So we're plugging 3 in for x. And if we do that, we'll get 3 squared plus 2. So we're just plugging 3 into that function. Well, can we simplify 3 squared plus 2? Because 3 squared is 9, plus 2 is, so what we have is f11, f of 11. Let's do it again, but this time we're plugging 11 into, which would be 3 times.
3 times 4 is 29.
Bless you.
Whoa. Doing my right now.
There's someone in there.
What was she? Oh, it's stupid. Oh, and they were.
And your shirt.
Was she working on that?
Yep.
Oh.
Was it your wife?
No.
That would have been cute.
We can talk about that here in a second. Let's finish this up first. Any other questions on this problem here? All right, guys. Come back in. Any other questions on this problem here? Let's look at this one here. So this time we're looking at g of f of -1. G of f. And again, we're going to work from the inside out. So we're going to look at f of -1 first. So we'll plug -1 into f of x, which would be our 3 times -1 minus 4. So after we plug that in, we can go on and simplify that down, because we can do 3 times -1 minus 4. We can plug that into a calculator and get -7, because 3 times -1 is -3, minus 4 is -7. Now we can do the same thing again, but this time we're evaluating for g of -7. So we're going to plug -7 into g of x, which would be -7 squared plus 2. Well, -7 squared, -7 times -7, which would be 49 plus 2 is 51. So this would be g of f of -1. And for any of these here, we're working from the inside out.
Yo, can I borrow your belt? That's so weird. Why would you say that?
See, I told you, right?
Thank
It'll
you.
make you feel uncomfortable sometimes.
Yeah.
I think when I said daddy hacks yesterday, he got uncomfortable. Did you?
Did you like
I-
the walk-up song?
Probably didn't quite hear what you were saying.
He says, I don't have the world.
I couldn't hear any of the songs. Yeah.
I just dropped it like
What was Stone's calling? I can only imagine.
Questions on this one? Questions on this problem here? Any other questions on evaluating these? We kind of like the evaluations, just working inside out. There's one last one I want to look at, and that's this here. We're not going to focus on the domain, finding the domain of these here. I just want to look at these two here so that y'all can So example 5, let f of x, yeah, they are, it's just one's f of g of x, the other's g of f of x. Now, for f of g of x, here we can go on and replace g of x with its function, which is Now, to do the next part, we're taking 2x minus 4 and plugging it into our f of x, replacing every x with our 2x minus 4. And this here would give us 2x minus 4 to the -1. And that's it. Now for these here, we'll leave it in this form. Normally we don't want to leave an expression or a function with a negative exponent, but here we're more focused on, I'm more focused on you being able to show the composite functions than that property of negative exponents. So we'll leave it in this form here. This would be your final answer for this. And that's all we have to do. This one here will be the last one that we're doing today. The last one we'll go over as a group. All right, guys. Let's focus in here. We got one last one. So here we have g of f of x. Now for us, f of x is x to the negative 1. X to the negative 1. So we replaced x with what it's equal to. Now we have g of x to the negative 1. So our g of x function, 2x minus 4, we're going to replace every x with x to the negative 1. So I have 2 times x to the negative 1 minus 4, which will actually give us 2 times x to the negative 1 minus 4. And this here is our g of f of, and that's it. So for the ones that have negatives with it, you just leave it as x to the negative 1. We don't have to correct that negative power as saying this here. We don't have to rewrite it so that the exponent is positive. Any other questions on this here?